Follow. Hey guys, I'm currently here with the class of 2020 in the background and the 2020 seniors. What's up? Math Life hashtag. And I guess if you guys want, you guys can follow along as I commentate. I mean, I don't know. I mean, right? I'm in quiz 12, Extrema. Extrema is Latin for extreme, if you did not know. All right, let's just get into it. I'm sorry, guys. Let's just go right in. All right, so the graph of f prime, the derivative of f of x shown below. Find the critical numbers of f of x. So the critical numbers, if you have an f prime graph, is just where it crosses the x-axis. So on this one here, it's going to be negative 4 and 4, and that's it. Let's go to the next one. On number 2, it says, suppose that c equals 3 is a critical number for f of x and that f prime equals that. Determine if f of c is a local max, local min, or neither. And yes, you could do a sign chart, but I'm going to do it even easier. I'm going to take a second derivative of this. So 3x squared minus 18x plus 26. And all you care about is whether it's positive or negative. So I'm going to plug in 3. So 3 times 3 squared minus 18 times 3 plus 26. So let's see what that is. 3 squared is 9. That times 3 is 27. Minus 18 times 3, 20, 40, 60, 246. That's 54 plus 26. Let's see, 27 and 26. 6, 25, 50, 52, 53. So I see 53 minus 54. I see a negative number, negative 1, if I did this correctly. So think about it. So that means that I am concave down and I have a critical number. So if you're concave down and you have a critical number, that is a max. So local max. Continuing. The graph of f prime is shown below. Find the intervals in which f decreases. So f decreases when f prime is negative. So f prime is negative where I'm highlighting. So negative infinity to negative 3. There you go. Next question. The graph of f prime is shown below. Give the intervals where the graph of f of x is decreasing. Again, it's the same deal. This is the derivative graph. I want to know where f is decreasing. So you're decreasing whenever f prime is negative. And it's negative from negative 1 to 0, and then 2 to infinity. So we look for that, and there it is, guys. Well, you guys have some comments? All right. I'll stop. Question 5. Find the critical numbers of this function and classify our local extreme values. So I'm going to take a derivative. So here we go. F prime of x is equal to 3 times 4. That's 12x cubed minus 12x. So I'm going to factor out a 12x. And when you do that, you have x squared minus 1 equals 0. So you go to 0 to find your critical numbers, and you find that x equals 0 and x equals plus minus 1. So that's what I'm going to look for first. Let's see. Critical number is 1, but it doesn't mention 0, so out. Critical number is 0, but it doesn't mention plus minus 1, out. Obviously, I chose this one, so it's the correct one, but let's keep going. No critical numbers? No, there's critical numbers, and critical numbers plus minus 1. So just by that logic, it's answer C, guys, but we want to do this the right way. So what you do is find f of 0, give me what that number is. Find f of 1, give me what that is. And find f of negative 1. Because it's symmetric, these two here that I'm circling are going to be the same number. So f of negative 1 is negative 4, and f of 1 is negative 4. And, just plug in a 0 into the original, and you'll get that number, negative 1. Where are you? Yeah, see right here. F of 0, negative 1, because that's 0, and then negative 1. So there it is. Let's go to the next one. Find critical numbers and classify local extreme values. You can actually do this without calculus, guys. This is just a rational function, so it looks something like this. So there are no critical numbers. That's just without calculus. But if you want to use calculus, let's take a derivative. So let's see. F prime equals bottom 4 plus x times derivative of the top, negative 4 minus top, 6 minus 4x times derivative of the bottom, 1 all over bottom squared. Now negative 4 cannot be a critical number because that's a vertical asymptote. So anything that says negative 4 you should immediately delete. And then when you do the top here, negative 16 minus 4x minus 6 plus 4x. Notice that these x's cancel out, and you just have negative 22 over 4 plus x squared. And if, there's no way this will ever equal 0. So if you put equal 0, it's not going to equal 0 because you don't have any x in the numerator. So no critical numbers at all, guys. All right, keep going. Question 7, find the critical numbers for this function and classify all extreme values given. Notice it's a closed interval. So you don't have to do a derivative test. You can just test your endpoints and your critical numbers. So f prime of x equals 2x minus 22. I'm going to factor out a 2, so you get x minus 11. I force that to equal 0, and you get one critical number at 11. So that's the only critical number. So what I'm gonna do is I'm gonna see what f of 0 is, and f of 0 is 6. I'm gonna see what f of 11 is. So I plug in 11. 11 squared minus 22 times 11 plus 6, and I just calculated it earlier. I get negative 115. And then you find out what f of 13 is. So f of 13 equals, and I guess I didn't calculate it. So let me calculate that real quick, guys. So 13 squared minus 22 times 13 plus 6. I got negative 111. So from there, I just choose what's the biggest and what's the smallest. So the smallest number is this one, and that occurs at 11, and then the biggest number is this one, and that occurs at 0. So I'll look for that. Critical number 11, absolute max, there it is, and absolute min at 11, there it is. So letter B. So whenever you have a closed interval, just test your endpoints and critical values. Find the critical numbers of this function. So here we go. X equals 0 before you even start. X equals 0 is a VA. It's a vertical asymptote. It is not a critical number. So delete anything that has 0 as critical number. Delete. And that's the only one that has 0 as a critical number. All right, here we go. F prime of x equals 8x. And remember, 3 over x is the same thing as 3x to the negative 1. So minus 3 over x squared. Equal that to 0 to get your critical number. So 8x equals 3 over x squared times x squared times x squared. 8x cubed equals 3. Divide by 8. X cubed equals 3/8, and then just take the cube root. Cube root. X equals the cube root of 3 over 2. They didn't do that. They left it as the cube root of 3/8, and that's fine. That one's out because that says 3/8. So maybe this one. No, it can't be this one because this one says critical number 0. Out. This one says no critical numbers. Out. It has to be this one. Of course, I want you guys to test it, but I'm just doing the shortcut here of if you want to get this test over with. But try and see that the derivative does change from negative to positive at that value, and it does. If you do the number line, here's f prime, here's 0, and here is the cube root of 3/8. Let's see. If I plug in a negative number, I'm plugging it into this one right here. If I plug in negative 10, this will be negative. If I plug in like a negative 0.000001, that's going to be a huge negative number because of this guy. If I plug in a 0.00001, sorry. So that's going to be negative. And if I plug in 10, 8 times 10 is 80 minus 3 over 100. That's 3 over 100 is really small. So I'm going to get positive. So notice right here, it goes from negative to positive. So that is a min. So there it is, local min. Continuing. Here we go. Find the critical numbers. I'm on a closed interval, so I'm going to take a derivative. F prime of x equals, the derivative of cosine is a negative sign, so get rid of this shenanigans here, that negative there. So 7 square root of 2 sine x, and then you're going to have to do a chain rule right here, guys. That is 7 parentheses sine x, close it, squared. So let's see if we can do a chain rule. 7 times 2 is 14, so 14. Leave the inside alone, sine x, and then derivative of the sine is cosine, so cosine x equal that sucker to 0. I'm going to factor out a 7 sine x, and when you do that, you get square root of 2 plus, let's see, 7 goes into 14 2 times, 2 cosine x. So you get, let's see, 7 sine x equals 0 if x equals 0 and pi and 2 pi. 0 and pi are my endpoints, so no bueno. I mean, those are critical points. And then square root of 2 plus 2 cosine x equals 0. Move the square root of 2 to the right, divide by 2. So cosine x equals a negative square root of 2 over 2. On the unit circle, that happens in quadrant 2 and quadrant 3. So x equals 3 pi over 4. And let's see, well, who cares about quadrant 3 because you're looking between 0 and pi. So that's my critical point. So let's see, maybe this one says no critical numbers. This one has critical numbers 0 and 3 pi over 4. But 0 is an endpoint, so we can't call that a critical point. Critical number 0 and pi, local and absolute, no, out. See, this test is kind of dumb sometimes. This is the only one that has critical number. It is an absolute min. Well, let's just do it like if we didn't know, right? So, test f of 0. I plug in 0 in here, guys, into this. So there is like a hiccup there. It shouldn't have the parenthesis like that. It should actually have that parenthesis around the x. Anyways, x of 0, sine of 0 is 0. Cosine of 0 is 1, so you'll get negative 7 square root of 2. And then you test f of 3 pi over 4. So let's see. Cosine of 3 pi over 4 is negative square root of 2 over 2. So you'll have negative 7 square root of 2 times a negative square root of 2 over 2. And then plus, and then sine squared here. That's a 7 there. So 7. And then square root of 2 over 2 squared. So let's see what that is. That turns to a positive. 7 times 2 is 14. Divided by 2 is back to 7. And then here you have, let's see, when you square it, you have 2 over 4, which is half. So plus 7 over 2. That's some positive number. So hold on to that thought. Maybe we'll calculate what that is if we have to. Let's test f of pi. F of pi. So f of pi, sine of pi is 0. And cosine of pi is negative. So negative 1 times that, it just gets positive 7 square root of 2. So, oh, hold on, guys. I'm going to have to pause this really quick. All right, we're back. I probably didn't look like a pause to you guys because I paused it. Haha, lol. Okay, anyways, let's see. Where were we at? Let me minimize this guy. F of pi is 7 square root of 2. And we have 7 plus 7 over 2. And if you want to know what is bigger, I mean, I guess you could always type this into the calculator and see what's bigger. But this guy here is the bigger number, 7 plus 7 over 2. Because this is 7 times square root of 2, which is like 7 times 1.57 or whatever. So this is the biggest number. So this is the absolute max right here, which occurs at 3 pi over 4. So absolute max at 3 pi over 4, 21 over 2. And then the smallest, well, this is the only negative number. So this has to be the absolute min, because it's the only one that is negative. So absolute min, f of 0, and negative 7 square root of 2. So hopefully that made sense, guys. Let me know if it didn't make sense, and we can talk more about it. Last question here. It says the graph of f prime, the derivative of f is shown below. Classify the smallest critical number for f. So since this is f prime, the smallest critical number I see is this one. So what is happening there? Well, f prime is going from negative to positive, so that must mean that I have a minimum. Let's go to the next one. It says the graph of f prime, the derivative is shown below. Classify the smallest critical number of f. Oh, I thought that was the same thing that we just had over here. Classify the small, yeah, same thing almost. All right, so this is f prime. Classify the smallest critical number for f. So here again, and I'm going from negative to positive, so that is also a minimum. All right, I hope you guys liked it. I think we are done here. And yeah, class of 2020, math life. All right, later, guys. Bye.